In our last video, we introduced the simple interest formula and how to calculate the interest accrued and then hence the total balance using this formula. In this video, we're going to take a look at how to use the simple interest formula to solve problems where we wish to find either the principal, the rate, or the time. So, let's begin. So let's consider the situation where I have $5,000 and wish to accumulate $1,500 more in order to purchase an item that I want. If I invested this amount into an account with an interest rate of 14% per annum, payable yearly, how long would it take before I earn this $1,500 interest? So, like in our last video, we start by listing down the simple interest formula, where I equals P R T. Now, I is our interest. Here, we know the interest that we're after. It's $1,500. The P, or principal, is the $5,000 that we initially invested. The R, or the rate, is going to be equal to 14% per annum, which, as a decimal, is 0.14. And the T in this problem is actually what we're looking for, so we don't know this value. From here, we can substitute the values into our formula. So we can substitute I, which is 1,500, which is equal to P, which is $5,000, multiplied by our R, which is going to be 0.14, multiplied by our T. So from here, I would simplify the right-hand side of this equation. So on the left-hand side, we've still got 1,500. 5,000 times 0.14 is going to be equal to 700, and we're still multiplying by T. Now to work out T, we need to isolate it on its own. So we need to perform the inverse of what this $700 is doing to that T. Currently, it's multiplying. So the inverse of multiplication is going to be division. So if we divide this right-hand side by 700, these two cancel out. On the right-hand side, we've isolated the T. However, whatever we do to one side, we must do to the other to keep it balanced. So we must divide the left-hand side by 700. Now to calculate what the T is, we can use our calculator. We can go 1,500 divided by the $700. Now we find that our answer here of T is going to be approximately 2.14. Now we've got to remember that T is always represented in years, so this is approximately 2.14 years. Now there is another way that we could have got this. We could have started with the top formula here, where I equals P times R times T, and isolate the T value before we began. To do that, we look at the P and the R, they're both multiplying the T, so we need to perform the inverse. The inverse of multiplication is division, so those two would cancel with each other, and on the right hand side we would have our T value. However, whatever we do to one side, we must do to the other. So on the left hand side here, we'll have I divided by P R. So therefore, T will equal I divided by P times R. So let's check this by using substitution. If we take this formula, we don't know what the T value is, but I is 1,500, our P is 5,000, and our R is 0.14. So let's put this into our calculator and see what we get. We've got our 1,500, that's going to be divided by 5,000 times 0.14, and look, if I press this button just here, it'll bring the same answer that we had before. Now just for your records, if we isolate the P value, our P is actually going to be equal to our interest divided by our rate, times our time. And if we isolate our rate, it's going to be equal to the interest divided by the principal multiplied by the time. So let's take a look at another problem. Sally is thinking about applying for a loan with an interest rate of 14.5% per annum, payable quarterly, and she wants to know what the maximum amount she could afford. How much could Sally afford to the nearest $1,000 if she could only pay a maximum of $500 in interest per quarter? So let's begin by recording the formula and the information that we have. Now, I know in this problem that I'm going to be looking for the principal. So I'm going to use the formula where P is equal to I divided by RT. Now, this is still the simple interest rate formula. It's just been rearranged. Now, my P value, I don't know. The I value here, I know is going to be a maximum of $500. So I put that. Our rate, or our R, is going to be 14.5%, which is equal to, as a decimal, 0.145. Now our time, once again in this problem, we have to be very careful. It's payable quarterly, so our time is going to be 1/4 of a year. Now the reason why this time is 1/4 of the year is because the interest value that we've got here of $500 is how much Sally can afford per quarter. So next, we substitute our values back into the formula. We don't know our P, so we leave that. The I is going to be 500. The R is going to be 0.145. And the T is going to be 0.25 as a decimal, which is equal to 1/4. So to answer this, let's get our calculator out. Now, we're trying to find 500 divided by 0.145 multiplied by 0.25. Now we find here that our answer is going to be $13,000, $793.10. Now this is an approximate value, so I need to show that. However, in our question here, we wanted to know the maximum amount that she could afford to the nearest $1,000. Now we have to be careful here, because if we simply rounded this value to the nearest $1,000, this 7 would mean that we would have to round the value to $14,000. However, Sally can't afford anything more than $500 interest per quarter. Rounding it up would mean that it would exceed the interest that she can afford. So therefore, we have to go against our normal rules and round this value down to $13,000. So the maximum principal that Sally could afford to the nearest $1,000 is $13,000. So now it's your turn. Here are a couple of problems that you can try practicing these skills at home for yourself.